Hi, I'm Pagra12 and today we play with Physarum, and for those of you who don't know exactly what this is, I suggest to watch this wonderful movie. And also Sage Jensen has a wonderful post in which we find this lovely drawing showing the process. And so we have a particle sensors, we use feedback for the trails, and blur and opacity for decay and diffuse. So yeah, let's start this from scratch. We build this parametric tool, and we can change the angle or the length for the vectors. Also, the speed has a consistent role here. So yeah, let's start from scratch. So okay. Now we use we build a particle system. So let's have a constant chop, and we chain a null here. Chain a null again in between, collapse selected. Now we have this folder, we name it data, and let's go in the constant chop and set resolution X, it's 1280. We have a ratio, let's go with 16:9. Also map X for the texture in which we keep the particles. Okay, let's go with 16 for now. We also have speed 0.625, angle, let's go with 24, and the length, let's go with 16. Okay, now inside this data, let's go and find out the resolution Y and also map Y. So we select resolution X and the ratio, and we rename this resolution Y, and here we chain a mod, and we go with divide, and here ceiling. Okay, now we have merge like this. We copy paste those two, as we want to have also the map. So instead of res X and res Y, let's go with map X and Y. And since we are here, let's have for our feedback the keyboard in. We use rename, and yeah, rename into reset. Okay. Now let's have in a base the starting position. Okay, so we call this base count, and yeah, let me open this window. Let's go inside here. Now let's have another base, as we would like to have an UV map here. So UV map. Let's go inside and use a ramp. So actually we need two ramps, so like this. One is taking the map resolution, and the second one will have the same resolution if we connect the input like this. Here in the output, set the resolution only, and for this map we go with vertical. Now we have a reorder, and this reorder takes input 2 for the green, and yeah, let's set this 32 RGB. Okay, now out. Okay, I would like to set everything to nearest pixels, like this. Now this is the UV, and we use a mod here in order to solve the ratio. And so let's have 1 divided by the ratio here. Okay, let's see this nearest pixels. Now the points, if we check the points, view as points, are oh, we need to mask the red as this solving for ratio. It's only happened on green. So now our points are good, and out of here we use a noise. Okay, we connect both of the inputs, set the amplitude to set the offset to 0. This is not monochrome. Let's go nearest pixels, and by this moment all the points went outside 0, 1. We go with the period very small, and let's have an out like this. Okay, what I would like to have the points inside the area, the region. So it's 0, 1 for the red, and 0 and 1 divided by ratio. So we have a null here. Click outside. Let's name this limit, and go inside where we need 2 limits. So limit 1, I'll have this red and mask the green, and yeah, let's set nearest pixels limit with zigzag in between 0, 1. Okay, and now the second one, let's have this green, and here we mask the red. Now all the points now are where they should be, so let's check them out. Okay, oh, not quite. So let's see, why is this? Yeah, because here in this we need to have zigzag maximum value. It's 1 divided by. Okay, now you see the starting position, it's inside the region, so we are good now. Okay, okay, now we need a vector direction, so let's copy this and we name it vectors. Okay, and since we don't have anything yet, we use noise. Okay, let's set the offset to 0, amplitude to 1, not monochrome. This has to be 32 RG. Okay, and let's use this map. Okay, okay, we go with the nearest, and right now we connect our output. We have some directions. Those are way too big, so let's have a mod here, for which we go with 1 divided by the resolution, and also we use speed. We drag it here to have it on Control X. Okay, and we multiply with that speed here. Okay, now we good. I would also like to bring here a normalized component. Okay, this is a very easy component, and now all the forces are equal. So let me go set everything to nearest pixels. Okay, and if we check now, okay, you see this noise, it's coming with different lengths for the vectors, and now all the vectors are 1 in length, and here we decrease the size. And we need to go in an add, okay, like this. But it has to happen inside a feedback. So first let's collapse select it. So we name this engine. Oh, sorry about that. Like this. And now let's go inside. So we have input 1, input 2. There are some differences in sizes, so that is not good. Here we have we drag an incorrect parameter for resolution Y. Now we are good. Here we use a feedback. So yeah, let's use the reset for pulse in reset and drag this add. And yeah, from the others tutorials we need to limit this, as they will keep going over and over. So let's go outside. In count we copy this limit and use it here in the engine, okay, like this. But both of the limits take loop instead. Okay, and now everything stays inside, right? Okay, now let's let's make everything nearest pixels. Okay, and we have an out here. Okay, what else? I would like to have a base, right? Let's call it render. Okay, so here we render out, and yeah, let me split the screen like this, and here we go inside the render, and in the render we use geometry component. Let's go inside and delete the torus. Now we come with the add SOP, we click add points, and we convert the point we have into particle by doing this, and set particle type to render as point sprites. Now we click on those two blue and purple flag, and we are ready for instancing. Okay, so let's go on here and drag the engine out. Okay, R and G. Okay, now here if we go with geometry, okay, we can't see well, as we need a point sprite material like this. So now let's have a look here. Okay, let's use a camera. Okay, this one is orthographic, bottom left and 2. Also render. For which we take this resolution. Okay, this one is 32 RGBA, and yeah, leave it like that. Okay, now let's have an out here. And yeah, let's set this blue flag here, as I would like to see the top here. Okay, now you can't see too well, as we are using point sprites and they are very small. Let's have 3 here instead. And yeah, let me split top and bottom, this one. Okay, and yeah, maybe I will have here I don't know, the network. Yeah, so right now we have the particles, they are moving nice, and we need three sensors in front of each particles as they move. Okay, so let's have here a base. We call it sensors. Okay, now let's go inside, and let's see, we need three sensors, right? So let's have a ramp, and we go 3 by 1. Okay, nearest pixels, and yeah, let's limit this with normalize. Okay, and this is 32 mono. Okay, now I would like to use a math here, as I want to multiply this range of values with 2 pi math dot pi multiply with 2. Okay, and now I would like to divide this with 360 degrees. Okay, and I'll have an amount for a 1 degree angle. Okay, and now I would like to multiply with 2 times the angle, as and multiply with 2, as we have an angle to the right and to the left. Okay, so, and let's set this to nearest pixels. Okay, and now let's have a function here. Okay, and we go with cosine, and yeah, let's set radians here. Okay, everything is good, and I'll mark this red, as this would be the value for the x-axis, and now I make this green, and yeah, we take sine. Okay, and now I believe we can use reorder. Okay, and we take input 2 for green, and this has to be 32 Rg. Okay, now let's see what we have here. Here we have, let me set these nearest pixels. Here we have 3 points. It's I don't know if you see this, but yeah, maybe if we increase, instead of 3 for the sensor, let's go with 16, right? And now we have an arc with 16 points, and we need to offset this in a center x-axis, right? So we do this here with -1 divided by 2, and now we have the sensors. Let's go back with 3. Okay, and we'll do a trick for easy computation with sensor, as we only need 3 sensors. What if I make use of the size, big size texture, and I have one texture for the right sensor, one texture for the left sensor, and one texture for the middle sensor. Okay, and in this way, doing this, it's much easier to compute between them, and for example, find out which has the maximum value. Okay, so let's do that. Out of here, I want to group the texture I have, let's go with 1 divided by 3. So now I have 1 pixel here. The middle one would be 1 divided by 3 to 2 divided by 3, and the last one, 2 by 3 to 3 by 3, which is 1. So yeah, okay. Now here we have the value for the left or right sensors, and as sensor has to stay in front of the motion for each of the particle, let's bring that texture in which we have the vectors. Okay, so let's use select. Okay, and from here we take this. Okay, and we can't see because the forces, the vectors are very, very small, and in order to see it much better, we can have normalize also here. Okay, but yeah, it's not necessary. Once you trust the mod, you don't need that. So okay, now let's use reorder here and grab the red. So I'll take the red. This is mono. Okay. Let me check now. I believe, okay, so this takes green. Both of them are 32 mono, nearest pixels. Okay. Let's mark this one with red and this one with green, and what we need now, it's function. Okay, and we go with arctan input 1, input 2, and you need to switch those two inputs. Okay, okay. Now this is where I have my radiance value for each of the particles directions, and I want to add the sensors. So we use add. Okay. Okay. And now we do this radiance to vector for all of them. Okay, so let's make for this one. Okay, and we actually can insert a null here. We go like this, and yeah, select this, collapse selected, and yeah, this is rad to vec. Okay, and let's use this, right? Okay. So we go with this for all the three sensors, and now we have the direction, okay, and we need to the length is 1 always here, so yeah, let's have this nearest pixels. Okay, because yeah, out doesn't took it, so now the out it's much better. So we can actually see this viewer much better. Okay, and from here we want to multiply the length to be as we set the length for each sensor. So let's go with because the length it's in pixels, so let's use a math. Okay, like this, and here we want to make this as small as 1 pixel, and then we multiply with our length. So 1 divided by, okay, and let's drag the length, it's here, okay, so like this. And with this little vector, we add it above the particle position, and then we have one of the sensor ready. Okay, so let's select particles position from the engine out. Okay, and yeah, don't mind the select. The select doesn't have the option to go nearest pixels. I know why. So add, sorry about that. So we add like this. Okay, and here should be the place for one of the sensors. So let's fix the others. So the other one here, we have an out. Like this, and again, okay, yeah, everything nearest pixels. Okay, now we have the sensors here, and I would like to check if the sensors are good. Okay, so let's go into the render and copy paste this geometry. Let's change the color into something else, red for example, green, let's say. And I would like to bring all the sensors with 3 selects. Okay, so yeah, let's bring the sensors here. Okay, now we use layout, and this layout should be 3 times the map. The 3 times the map X and the map Y. Okay, and here resolution, and yeah, let's make this nearest pixels. And now I would like to use this texture. Let's rename this into sensors and drag it here. Okay, and yeah, it's not quite good, as the sensors, you see, they are not in front of the motion. So let's go here and yeah, try to, no, okay, let me check this one. Okay, yeah, it's a little bit strange, so let me see if I can fix this. It seems not yet. Okay, what did I did wrong. Let me check. Okay, this is good. Okay, we are good here. Oh, okay, I will pause this till I find the error. Okay, sorry about that. I had a little smoke while I found the error. So yeah, the error, as you see now, the sensor seems good. They seems to stay in a certain angle. Okay, and the problem was here in this function in which we go with red and green in a inverse order. Okay, this has to take radians, and now you see the sensors are staying in front. So let's check now. Let's go with 90 degrees. Okay, so yeah, this is good. Okay, we can change the length to 1. It's 1 pixel, and now it's 10 pixels. Okay, oh, we are good. And yeah, we need to build a trail. Okay, and let's go inside here. Okay, now that we know the sensors are good, we don't need them. Okay, here I would like to use a simple feedback. So let's take a feedback, not feedback edge. Okay, like this. And yeah, let's use the reset. Okay, let me check. I'm not sure this is the window. Let me check again. Okay, from here. Okay, so as I have another the Touchdesigner open, so let's drag the reset here. Let's have this 0.99. Okay, let's go inside. As we don't use a wet dry mix, let me clean this feedback a little bit. Okay, like this. And yeah, customize components, we delete dry wet. Okay, and we have straight lines because our noise is not moving. Let's make this noise moving a little bit. So ABS time dot frame divided by 1024. Okay, okay, now they move nicely. In the paper was something about decay and diffuse, and yeah, let's go inside here. Now I can go with this is let me check again, because yeah, the decay is done with this opacity here. Okay, now I can make a blur also, and we can go inside, but I prefer to have the blur outside. So okay, and yeah, in the case I want to try a blur inside, just in case, yeah, it will be the same small amount like I use outside. It's just the 2 for the filter size. Okay, so just a little bit of noise, you see, a little bit of blur, sorry about it, but yeah, we'll take it out from now. So let's check, we have 2 here. Okay, now we are good. We need to make the computation between the sensors and see which of the 3 sensors read the highest value. Okay, now that means we trail the particles, and yeah, if the value is high, the the particles went there frames ago. So let's build a base. Okay, and we name this compute. Okay, and let's go inside. Now inside here I need 3 selects. So let's go again, select 2, 3, okay, and we take the sensors in those 3 selects. Okay, so 1, yeah, I use this one first, second, and the last. Okay, and I want to check where the sensor are in this layer. Okay, and I use remap for this, but first let me use another select. So we need to take the render out this texture with the trails. Okay, and we remap this texture with what we have here. Now every time we use such a texture for remap, that this texture should be normalized in between 0 and 1. This one is with the ratio in it, so let's go with the matte. We mask the red and we multiply with ratio. Okay, now let's make those nearest pixels. Okay, and we copy them for all the sensors, so 3 times. Okay, now here I would like to check which one is bigger. So let's go with a composite like this, and here we go with the maximum. Okay, and now I want to compare this maximum with all of them, and we use a matte, because where they are identical, if the maximum is in this one, I'll have here, by making the difference, I'll have 0. So if in this matte I go ceiling, all the points that I'm not interested in are getting white. Okay, but I need the other two, the other ones black, so I go with a level and invert. Okay, okay, now let's make sure everything is nearest pixels. Okay, and now we do this for all 3 textures. Okay, okay, and here I'll have marked with white where is the maximum. So I need to pick for that maximum, I need to pick the direction where my sensor tells me. So let's do that. We use a select, and we select out of engine, this time engine out. Okay, here we have the particles position. In those 3 we have sensors position. If we do a subtraction, so subtract, so let me see, I subtract this minus this. Okay, so now I multiply this texture with this subtraction, and this is the direction where I should go if the maximum is in this sensor. Okay, so let's have an out Okay. Now we do this for all. Okay, but yeah, we need to make this also a couple of times. So copy 2 times, right? Now let's connect this one here and this one here, like this. And now, okay. So I have those 3 substracts. Okay. And here I add the results. Oh, not with add. Instead, we go with composite, okay? And we take add. Okay. Now let me check my screen. I hope everything is good. Okay. Just a moment. Okay. Yeah, let's see. So first let's set everything to nearest pixels. Okay. And now we go back into vectors, okay? Now we should take the output from compute and bring it here. So for this we go with a constant and we set the resolution as we have the map. Okay, this is 32 RG, and yeah, let's set this to 0. Okay, 9 instead of, okay, like this. So now we have a feedback, and we bring the compute out into the feedback. Okay, we use the reset for the pulse and reset, and yeah, let's bring the normalize again. Go inside, make sure everything is nearest pixels, and let's see. Oh, everything I said, right? Okay, and let's see now what's happened. Now you see the lines takes certain directions, and the particles follows other particles, and yeah, let's see if we change the parameters now. Okay, let's go with 256 particles. Okay, now yeah, this is correct. Finally, it's been a 5th time when I try to have this in less than 1 hour, so it seems we did it. Okay, now let's use here even a bigger texture. Okay, and we need to go in the render and yeah, make those points normal size, like 1. Okay, and this is Physarum. We can play now with speed. If you increase the speed, okay, by a lot, you might see some dots, but yeah, it depends. So now you see, if let's say, well, let's jump with 8, you see the dots. Okay, so now let's see how we can modify, how we can control this. And as we finished quite early, because I was planning just to walk you through some of the tricks, but yeah, we'll have them here. Okay, so first one, let's have even a bigger number. Okay, let's have 1,000,000 particles, right? And right now, let's go here and use a noise, okay, like this, and not monochrome. And let's set the amplitude to 0. And by the moment you increase the amplitude, okay, yeah, some things go strange directions, as yeah, this noise have influence. This noise will influence the precise direction. Okay, what else we can have? Okay, if somehow when you start you have a certain direction, all of the particles go mostly in one direction, let's correct that. So instead of this constant, I'll have this noise, and now it's something else, right? So we don't need this anymore. Okay, let's have this feedback black. Okay. Another way you can change, you can modify the output, okay, is if you use here in this after this feedback, if you use, let's say, sharpen. So you go with sharpen like this here. You can always go inside and make sure this convolve is set to use input pixel format. Okay, it will be much nicer. And yeah, let's play with this. Okay, so also you can reduce for some of the parameters. You can reduce this opacity. Okay, some of the outputs can look nice with less feedback. Okay, let's try to do something else. Okay, and let's bypass the sharpen. Okay, what if for some of the particles I have a certain length, for some other particles I have different angles? Okay, how can we do this? So yeah, let's go, let me check a little bit. So let's go in sensors. Okay, and let's have a noise, and this one should be the same with the map resolution. Okay, okay, and all the 32 mono, all the values 1, and yeah, amplitude 1. If now we use a multiply, and we multiply this right here, so we multiply this. Oh, sorry. Okay, so only one line. Okay, now, oh, Control C, Control V. Okay, so I would like to have a noise, and that one will affect the length actually, right? And one more. Okay, okay, now if now I play with this noise, okay, some of them goes faster than the others, because the sensor here it's way further. Okay, so yeah, you can see better if we decrease here. You see, so you can get those type of variations. And you can also do this type of noise and multiplication here for the value for the radian where the sensor should be. If you multiply that with a certain noise, you have some variation. And yeah, I'll have that back in a file that I share with you. So yeah, let me show you. Because okay, so if I want to check this instead, okay, not here, let's go like this, right? So let's see what we have different. So yeah, I have that noise here, and in sensors I have this multiplication with a noise for which I can go with certain parameters, and yeah, also noise here, a different one, which makes some variation in the length, and this noise is mapped on where I have the particles engine out here. Okay, so instead of doing this, yeah, I just used another select. Okay, and yeah, this being the only difference. And what I did different for this one is name this folder buffers. Okay, and have only the render, and then in post I have the feedback and sharpen and so on. Okay, now I did this because sometimes here in the buffers you want to have some different textures for different type of computation. Remember the normals we did in previous tutorials. So yeah, this was my tutorial. I really hope you like this. Thank you so much for watching.